Hey everybody, CJ here, your local friendly technology addict, and this is the Tech Addict Addict. I just spent about an hour through several takes trying to make a video. The build process for this device that I'm about to show you. And honestly, it would be better if I showed you the destruction of this device. No, it's not a bomb or anything. By destruction, I mean literally the disassembly. What we have here is called a Voltaic Pile. It produces enough voltage, barely, with enough current, barely, to light this fairly common LED, light emitting diode, okay? Now I know my phone won't stay focused on it, but that's it. I want to turn the light on here so we can actually see what I'm doing. And you can still see, even with the light on, that lights up now. There's nothing special here, okay? Not that my phone would ever focus on anything I want it to focus on. If I move it out here, it won't focus out there either, usually. But there's nothing special about it. It's just a common LED. And I'm only holding one lead of it anyway, so it's not like I'm producing a voltage that way. I'm going to move this out of the way so you can see there's nothing underneath it producing a voltage. And let me go ahead and turn on my voltmeter, which is set for, well, not that you could see it for the phone's shadow, but it's set for the 20 volt DC range. I want to take these leads. You can see it's producing 3.12 volts. Now, when I first built it, it wasn't producing that much, so I think what has happened is the electrolyte has balanced itself out a little bit, but I'm going to go ahead and start taking it apart. Piece by piece, for the most part. Now, this came off in basically 3 pieces. We have on one side a common United States 1-cent piece. On the other side, a common United States 5-cent piece, commonly referred to as the penny and the nickel by Americans. Nothing fancy about it. I've roughed them up with sandpaper a little bit to make them leave a good surface for the electrolyte. And this is nothing but a paper napkin, common everyday dinner napkin, okay? That you can see I've folded this one in a previous take to show how I've cut it basically into 16 even-sized squares, and then folded those up and made 8 even piles. And then for an electrolyte, I have them soaking in pickle juice, or what we call pickle juice, and I just knocked over my pile. Once you get rid of the fresh cucumbers, you're left with, if this thing would ever focus, water, salt, and distilled vinegar. So basically vinegar or acetic acid mixed with salt water. Well, this thing has come apart rather nicely, so I may as well go ahead and stack them back up. But just to show, penny, nickel, electrolyte pad, okay? There is no sleight of hand here. These are just regular coins. Now, why does this work? Well, back in the 1800s, late 1700s, early 1800s, there was a gentleman by the name of Alessandro Volta who paid attention to scientific journals of the day and read in those journals that his contemporaries were doing some interesting things using frog legs, brass hooks, and pins of another metal, which I think were probably zinc. I don't really remember. I read about it, and you know how it is. You forget the details. Well, this one came apart that way. But there's nothing untoward here, nothing hidden. No, like I said, no sleight of hand. Just pennies, nickels, and pieces of paper with briny vinegar. Now, the vinegar basically is acetic acid, and then the salt and water make up, of course, salt water, which in itself is an electrolyte. But that's pretty much all we have is, let's see, 1, 2, 3, 4, 5, 6, 7, 8 nickels and 8 pennies. And between them they make 3 point some odd volts. Nothing special. And I had them sitting on a piece of aluminum pie tin. And that was enough voltage and current to light up an LED, as you saw. So there's nothing special here. So why does this work? Like I said, Volta was reading the journals about his contemporaries doing some experiments with frog legs. Whenever they would hook the frog leg on a brass hook, and then they would poke the frog leg with a pin of another metal. And when they did that, the frog leg would twitch. Well, what they did not realize is they were inducing an electrical current into the frog leg, of course contracting the muscles as they are designed to do, and we wind up with the frog leg twitching. Well, Volta had his own hypothesis on that. The contemporaries came up with several ideas, but none of them were quite on the mark. But Volta, with his hypothesis, was pretty much on the mark. And that's one of the reasons why he is credited with the discovery of voltage. Hence the name, voltage, Voltaic Pile. So that's something else, is we traditionally call it a battery. It's actually a cell. It's not a battery until you have several of them together in a kind of an arrangement like where you have them in parallel or in series. But we call it a battery even though it's a cell. But if you were to look at the Spanish word for battery, it's the same letters that make up our word pile. Pile. Pile alkaline. It's a pile, okay? Voltaic pile. And all he did is he had coins. Well, not coins. He didn't have coins that he used. He used actual pieces of metal. Well, not that these aren't pieces of metal, but you know what I mean. He didn't use coins. He used purpose-built pieces of metal. And his were, I think, brass and zinc, or maybe brass and nickel, or they were bronze, something along in that family, along the same lines as copper, and something along the same lines of either zinc or nickel. Now, American coins are alloys. This is a copper penny, but if I were to cut it open, in the middle you would see zinc, okay? So this is copper-plated zinc, or copper-clad zinc. And the nickel, I forget what it's made of, but it's not nickel. I think it's a zinc and copper alloy. Now, yeah, there's still copper in it, but it's an alloy, and compared to the full-fledged copper surface that you get on the penny, it's still different enough that we can induce current to flow. So, chemically, the electrons in the outer orbits of the one material flow through the electrolyte, the pickle juice, toward the other material. Or they don't really flow, but they create this kind of a pressure, if you will, voltage. And it's not until you create the circuit, finish the circuit, like with an LED, that the electrons can actually flow. And that's the basic principle behind a battery cell, is 2 electrodes, an electrolyte in between them, and then you create the circuit. And in that circuit you can add more cells to make it an actual battery or what have you. So there you have it. There's nothing special about that. It's just a pile of coins and pickle juice. And I love me some pickle juice. I think I'm going to drink some now. So that's the 3rd video in a series. I don't know if I'm going to put these all 3 together or not, but there you have it. Until next time, I'm CJ, your local friendly technology addict, and this has been the Tech Addict's Attic. Take care.